Hello, and welcome to the Physics Simulation Overview. Today, I will show you how to use Vpython to build two electric field simulations. Also, I used Ruth Chadby's simulations as my guide. We will start with the drag sim simulation. As you see here, in this red sphere, this represents a positive charge. And we can move around this positive charge with our mouse. The orange arrows are the resultant electric field due to this point charge. And as you can see, it can affect everything in a 3D space. And the arrows change based on where the positive charge is. We can also change to a negative charge. And so the arrows come in instead of out. And as you can see, now it's a blue sphere. To build this simulation, first we need to set up our scene. We will first give a width, a height, a background, and a range, and also a center. Next, we will build some variables to store some information in. First, we have the obslock variable, which holds positions of the observation points in the space, or in the spine, where the electric field is being calculated and then visualized. The observation points are these little orange dots, as you can see in this scene. Next, we have the arrows, which holds the electric field vectors that represent our arrows in the 3D scene. Next, we have a constant we want to define as k. Now, we set this as 15 just for visualization. This is not the actual value of k, but for the visualization, it makes it much easier to produce. Next, we want to create a charge that we will have a sphere. Call it charge pos. We'll make it red, give it a radius and a charge. And this entire little thing will help us create a positive charge. Next, we want to generate our observation points, which will have all of this to help build it in the X, Y, and Z. And for each point, an arrow is created at that point, and the electric field is calculated right down here using Coulomb's law. Next, we will caption this to help everyone understand what is actually happening in this simulation. Next, you build the variables for the drag states, and also make a function to toggle the sign between positive and negative, and also help change the color if we want to change it. And if we change it, it will recalculate the electric field due to that change. So the arrows will go in, out. Next, we will make a function to help grab the charge. And so, then, we can make a function to help move the charge. And during that movement, we will set up a little function down here to recalculate the electric field due to that movement. As you see, the electric field recalculates every single time it moves. After that, we will make a function to drop the charge and basically reset it to a neutral state. After that, we will make a toggle button so that we can actually toggle between positive and negative charges. And then create our bindings for our mouse to grab, move, and drop. And that is all for the drag sim simulation. Next, we have the electric field simulation. As you see by this 2D visualization, these arrows get shorter over time. We also can build a 3D view showing arrows in the Z direction. We also can make the charge negative, so the arrows point in now. And as you can see, it's still stronger when close to the positive charge or negative charge. And the farther you get, the smaller they get. Now, for the code, you want to set up again using the same type of commands. For this window, we don't need to make a center. After that, we need to define some constants. Now, for this constant, this is Coulomb's constant. This is the radius of our charged particle. This is the shaft width for the arrows. This is basically how wide these arrows are. If we change this value, they would be thinner or thicker. And the scale factor is how we scale up our visualization so we can actually see. You also could do it with this one. However, I couldn't really create an amazing one like this one. And so next, we want to make a new particle, a sphere with the ability to be a vector, a red color, and a radius. You can also set the charge right here. And we're going to make some angles because our arrows will want to be at different points. I mean, it'd be really weird if all the arrows were like right here. So we create different angles to go all the way around. And next, again, we're going to make some more lists. Here's the first one for arrows that holds the 2D arrows. And this is the second list that holds the 3D arrows that we can add in using this button. Now, to create the arrows, we first use this function, which will build all our arrows around the positive charge. And next, we need to calculate how long these arrows are using Coulomb's law. And after that, we need to create a function to determine if we want it in 2D or 3D. And after that, we need the ability to have a function that changes the particle from positive to negative and also changes color. And also change where the arrows are pointed. And after that, we need to have some buttons for a 3D view to turn on and off, and to make the charge negative or positive. The point of these simulations is to help visualize these weird phenomena that we can't really see with our eyes, but we can see with a simulation. I mean, I can't see an electron or a positive charge, but this simulation makes it possible to see them. We also cannot see electric fields, but with these visualizations, now we can. Thank you for following along. I hope this overview of Vpython electric field simulations have helped you learn how to create and visualize electric fields in 2D and 3D. You can feel free to experiment more with this code and improve on it. Thank you.